Hi, so for today we're going to talk about empirical and molecular formula. So when we talk about empirical formula, it is a type of formula that is used to express the smallest ratio of the atoms in a compound. And when we talk about molecular formula, it is used to express the actual number of atoms present in a compound. So I have here different problems involving how to get the empirical formula and how to get the molecular formula. So for the first problem, a certain substance has a molecular weight of 86.2 with an empirical formula of C3H7. Find the molecular formula of the compound. So for the first step is you need to calculate the formula weight of C3H7. So how do we get that? First is we have here the mass of carbon. So we have here the molar mass of carbon, which is 12.01 gram per mole, multiplied by the number of moles, which is 3. So we would get 36.03 grams. Next one is we have the mass of hydrogen, which is 1.008 gram per mole times the number of mole, which is 7. We would get 7.056 gram. So adding these two mass of carbon and hydrogen, we would get 43.09 gram or atomic mass unit. That's the first step. And this is the formula weight of C3H7. So we will use this formula weight in getting the molecular formula. So second step is calculate the ratio between the mole, molecular, and empirical weight. So we have here the molecular weight, which is given, which is 86.2, then the empirical weight that we got a while ago, which is 43.09. So dividing 86.2 and 43.09, we would get an answer of 2. The molecular formula then must be twice the empirical formula. Hence, multiply the calculated ratio with the empirical formula of the compound. Therefore, the answer would be C6H14. That is the molecular formula of the compound. So for the second problem, it involves the computation of the empirical formula. What is the empirical formula of ascorbic acid, known as vitamin C, which is 40.91% of carbon, 4.57% hydrogen, and 54.50% of oxygen? So the first step here is you need to convert the percent composition to an actual mass. So we always assume that we have here 100 gram of substance. For example, we have here 40.91%, we would convert it into 40.91 grams. Okay? Second step is we need to convert the mass to moles of each element by dividing it by the atomic weight of the element. And for the third step is find the whole number ratio of the different elements by dividing all moles of the elements present by the smallest number of moles. So for the solution is again, so we have here carbon, on which we converted the percent into grams or into mass. So it will be 40.91 grams divided by its molar mass, which is 12.01 gram per mole. Second one is we have 4.57 grams divided by 1.01 gram per mole. And for oxygen, we have 54.50 gram divided by 16 gram per mole. Computing this one, we would get an answer of 3.41 mole, 4.57 mole, and 3.41 mole. The next step that you need to do is we need to divide the computed moles with the smallest mole, on which the smallest mole that we got here is 3.41. So divide all the moles that we got by 3.41, so we would get an answer of 1, 1.34, and 1. Now, these numbers, 1, 1.34, and 1, would be the number of atoms present on the empirical formula. But in writing chemical formula, we cannot write numbers with decimal. So in order for us to get a whole number ratio or a whole number, so we need to think of a number on which if we're going to multiply it, it will become a whole number. So we have here 3. So we multiply all the number that we got by 3, on which 1 times 3, 1.34 times 3, and 1 times 3. Therefore, we would get an answer of 3, 4, and 3. So this number is now the number of atoms present on the compound, on which carbon will contain 3 atoms, hydrogen will contain 4 atoms, and lastly, oxygen will contain 3 atoms. Therefore, the empirical formula for the ascorbic acid is C3H4O3.